I'm just setting up this YouTube thing. I think we are live, if I'm not wrong. Yes, we are. I hope so. Okay. We can also see a lot of people out there. Okay, let me just click on. Okay. Okay, perfect. We are live on YouTube as well. Then it's great. Okay, guys. Hello. Hi, everyone. So to begin with, I'll probably thanks a lot everyone for joining us. And here we have Sai Gayatri. As you all might be aware by now, she's a data scientist at Tetrasoft, and she has already been impacting a lot of learners through her articles on Medium, and also she has a small YouTube channel as well. She has been maintaining all these things for a while, but paused it for quite some time now. But that being said, she also at her personal capacity, she tries to help data science enthusiasts in her hometown, and she takes classes over the weekends as well. So that's Gayatri for you. And now to begin with, I'm hoping every one of you have already gone through the preparatory modules that we have given you. However, if someone might have missed out, probably what I would do is I'll just quickly share my screen and show you, take you through the sessions. Just one moment. And I hope everyone is able to see my screen. So just to give you some quick introduction, right? In the preparatory material, we have asked you to learn about arrays, vectors, and matrices. To begin with, we'll talk about arrays. What exactly is an array? I mean, by now you might have known it because it's similar to a list. And however, just give me 1 second. Yeah, it's similar to a list, and it's also it's a data structure basically. And by now you have learned about a bunch of data structures, right? Tuples, lists, and other stuff. However, the only catch that we have with arrays is it can hold only a collection or ordered series of elements of same type. When we talk about same type could be it could be a string, or it could be an integer, or it could be a float, things like this. So it can only hold one variety of such data types. Okay, that's the only catch that we have with strings. And why do we even use arrays? Okay, arrays basically reduce the overall size of your code. And as we all know, we try to write some optimal code, or come up with an optimal solution always, right? So we always want to optimize stuff, and that's one of the reasons why people use arrays. Again, coming to list versus arrays, I think I have already explained you what is the difference between a list and array. In list, you can technically use any type of data types to store a value in a list, whereas in array, you can only store one type of a data type. So that's the major difference between lists and arrays. And coming back, okay, here we have some mathematics. I mean, here we have vectors, and also we have matrices. I think just to give you some heads up, vector is nothing but a type of array that is one dimensional. Again, what are dimensions? Just to put it in a very short form. So if you take a box, right? A box would have length, breadth, and depth or height. Okay, it has 3 dimensions. Similarly, when it comes to vector, it is a one-dimensional array. And in context to data science, we will be working with some n number of dimensions. Okay, and we also call them as variables when we start talking about it in next few weeks to come. We'll definitely discuss about it. So yeah, that's some introduction about vectors. And coming to matrices, it's again an arrangement of rows and columns. Okay, it's just we have already given you a simple explainer in this particular link. You don't really need to worry much about these terms. You will get used to it over time as we proceed further. Okay, it's just that it is also in matrices, you also store values of any type, any number of dimensions in the form of rows and columns. Okay, and probably now I'll let Gayatri take over the session. I think this is pretty much about it, and probably she'll help us out with the remaining things. Gayatri, you're able to, okay, let me stop sharing my screen. You're able to share your screen now?
Yeah. Thank you, Chanukya.
Yeah, great. Yeah, go ahead.
So now that we got a little refresher of the important basic concepts, so let's get started with NumPy, or the numerical Python, the library that has been made for scientific and mathematical computations. So um, before we even plunge into learning about a library, let's try to understand what is the necessity to even learn a library. So for that, I have a data set here. A small iris data set, which is like very famous in data science community.
Yeah,
So
Gayatri, one
yeah.
small thing. I think you need to share your screen.
Oh
You
wait.
didn't. Yeah,
Oh sorry.
you're able to do
Host.
that?
No. Host disabled participants group.
Okay, 1 second. Yeah, just check it out now.
Yeah, I'm sorry.
We're really sorry, guys. Yeah, go ahead. Yeah,
Yeah.
perfect. We are able to see it now.
So before we even get started with what numerical Python is, so let's look into a data set so that we can understand what is the need of this NumPy itself. Okay. So here, this is an iris data set, which is like very popular with the data science community. So this is a data set of flower called iris. There are about 3 classifications of this flower, which is Setosa, Virginica, and versicolor. So what this data set tells us is if these are the attributes of this particular flower, which is sepal length, sepal width, petal length, petal width. So depending upon the sepal length, sepal width, petal width values, a particular flower will come under one class, which is Setosa or versicolor or Virginica. Okay. So that is like if the sepal length is 5.1 and sepal width is 3.5, petal length is 1.4 and petal width is 0.2, it comes under the classes Iris Setosa. So uh, so let me explain some terms with respect to this data set. These are called as attributes or dimensions. So as we have seen before, the dimensions in the box structure which Chanukya has helped us understand. So these also constitute dimensions. Now this is nothing but the output variable or the class variable which we are trying to predict. So this is basically a classification problem which we would be learning going forward. So before even thinking of all this, so let's try to answer a few questions to ourselves. Okay. So what do we see in the data set? Some attributes and some. This is all a numerical data and this is a categorical data. So numerical data is nothing but numbers. Categorical data is nothing but which tells us about the classes in that particular data set. So that's something which we observed just by preliminary screening of uh, the data set. And what is the type of data that is present? Primarily it is a numerical data, right? And so if it is a numerical data, what kind of operations can we do? Like these columns we can add them up, we can do multiplication of them. I'm just telling we can do different types of mathematical computations given these all are numbers, right? So one more thing, so when we want to do these kind of computations, instead of doing it step by step or like by looping through this particular columns, we can do them with the help of certain libraries which data science gives us. Because here we could see that the data set is small, it has only 150 instances, it is a small data set, but and the number of dimensions or the attributes is also very less, right? It has only 4 attributes. But when it comes to bigger data sets, there would be more very high number of dimensions, and also the instances or the data points or the number of rows also could be very high. So we cannot manually do all these things like spending more time. So that is where these scientific libraries help us out. So that's why we need these libraries like pandas, numpy, matplotlib, and scipy. So as we go forward, we will learn more about these libraries. First library which we are learning today is numpy. So before that, which Chanukya has already covered, I will just give a very fast refresher of the mathematical entities. So as already we have known that array is a data structure typically of same data type. Please do remember this, that array is a data structure which has similar data type objects, because in NumPy we are going to deal with arrays mostly. And what is a vector? vector has its significance, like right from linear algebra, it is very important. This is a row vector. This is a column vector. As you can see, this is the elements are arranged in a row order, like one by one. This is a row vector and this is a column vector. So more about it is available here. They have given good operations and everything that is needed for with respect to vectors. Now let's talk about matrices as well. So let's try to understand what is the shape of this particular matrix. So what is the number of rows that we have? 2 rows and 3 columns. So this is a 2 by 3 matrix. And this is a 2 by 2 matrix. This is a 3 by 1 matrix. This is a row matrix. This is, sorry, this is a column matrix. And this is a row matrix. And this is 3 by 3. This is again 2 by 2. So, and these matrices, we can see that it has got real numbers as well as complex numbers, imaginary numbers. Now, so in a matrix, we can do all these mathematical computations of real numbers. That's what I wanted to point out. So also, so since we have been learning Python list for a while, so you must be knowing that lot of these things like creating these rows or creating these vectors can be done Python list itself. So Python list itself can have, also we know that in a list we can have integers, strings, we can even have other lists in the given list, right? List of lists also can be made. So when we have lists, why do we need a something like NumPy? So that is what we are going to understand. Like, let's keep it as a context like Python list, and let's try to build up on basis of it. Why do we need NumPy when we have lists? So uh, so these are the operations which can be done in list, right? We can append them, extend, we can have contain other list as well. And particularly in list, we can save the sequence in which the elements have been ordered, right? So when given all of this, why do we need NumPy? That's what we are going to understand now. NumPy is known as numerical Python. It is mainly designed to carry out mathematical computations at a faster and easier rate. Further, this library enriches the programming language like Python by providing powerful data structures like multidimensional arrays. So as we go forward, we'll understand what these multidimensional arrays are. We already know about matrices and linear arrays, vectors. So matrices are two-dimensional objects. Linear arrays are vectors are one-dimensional objects. So beyond these two-dimensional, one-dimensional, and three-dimensional, we can go for more number of dimensions up till thousands as well with NumPy. Okay. And apart from all this, giving us data structures, NumPy has got good, very nice mathematical functions, which you don't need to write code for that. You just have to use that function which is already available and carry out the like the amount of code which you're writing, the amount of time which you're spending also gets optimized with the help of library like NumPy. Okay, so before we learn further about NumPy, I would like to help you out with how to install NumPy. If you want to do it in your command line, just put install NumPy. You have got Anaconda distribution, which helps us in creating different environments and version control. Anaconda distribution is a very good platform. So there you can use Conda install NumPy. Also, like most of us right now are using Python 3, so it is pip3 install NumPy that can be used. Now, so I think I'm very much clear. If you have anything to tell, please put it in the chat window. So now let us try to understand what is the need of Python list versus NumPy. So here I have taken this code snippet from this website. So what I'm trying to do is there is this vector of size 1000. I'm trying to create that an X list and a Y list with 1000 elements each. So these are nothing but the Python list. Now I am even creating NumPy arrays. So creation of NumPy arrays, you can use this code np.arrange of. Here also I'm using 1000 elements. So this X and Y lists have got 1000 elements each, and this X and Y NumPy arrays have got 1000 elements each. So what I would like to do with this NumPy arrays is that I just want to perform a small addition operation, like element by element operation. So for example, if I have two lists like list 1, list 2, I want to perform 1 plus 4, 2 plus 5, 3 plus 6, 4 plus 7. So element by element operation. So for that, if I want to use a pure Python version, so this is how I can do it. X list of I plus Y list of I for I in the range of length of X list. This is nothing but a list comprehension where I'm doing it. You can see that I'm looping through the entire 1,000 elements to perform this operation. That is, I'm performing like 1,000 operations to get this addition of these two lists, X list and Y list. But if I want to do the same thing with NumPy version, all that I have to do is just write down X plus Y. You can, this is nothing but called as vectorization, that we have taken out X and Y as two vectors and we have just directly added them up with very less, like one operation. So this is the primary advantage which NumPy gives us over Python list, that is vectorization. Next important uh, advantage that we have is the time that it takes. So for example, this particular code enables us to understand what is the amount of time that is being taken by Python version to run and what is the amount of time that NumPy version is going to take. Let's see. I'm going to run this code snippet and let's see the amount of time that it takes.
Yeah. Gayatri, one quick thing. Can you zoom in a bit? A few users on YouTube are saying that, like, it needs to be zoomed. And also, I think we have two questions here. One is like, okay, what is big data? What is the meaning of big data? Bhavya has asked it. Yeah.
Okay. So big data is, it corresponds to the amount of the data that is present. Okay, the data sets which we get usually is from like data warehouses, databases. So all these different data sets, like which, let's suppose if we want to create something for a user, let's think we want to create something like a recommendation system for a user interface. For that, like the amount of user data is all being stored in the form of databases and data warehouses, also in data centers. So that amount of data put together is in very huge quantity. That is understandable, right? So that particular data has to be, before we even put it to data science projects, like before we perform these data science uh, like uh, modeling and prediction process, we need to take up some additional operations for pre-processing and pipelining of data. So big data covers all that pre-processing and pipelining, which further helps us so that we can carry out this machine learning and data science modeling as a next step. I think I made some sense.
Yes, yes, it did help. I think, like, you have put it, and also, like, we can probably take it up later too. It's more to do with data extraction and a bunch of other things, right? So I think, it's put well. And one more quick thing, Gayatri, I think, like, users wants it a little slow. I think, like, you're going great, but it's just like, a little slow. That's it.
Oh,
Yeah.
okay.
Yeah. Okay. Thanks. Yeah.
Thank you. Please do interrupt me and tell me like whenever these kind of changes have to be made, because I
Yeah,
cannot
sure.
look into the chat window right now.
I know you are blinded. I'll help you moderate. Don't worry. Okay.
Yeah.
That's just a request from the community. Yeah. Thanks. Yeah.
Thank you. So now I think this made sense, right? So what I'm trying to do is add, these are the two lists that we have, X list and Y list. So taking up these two lists, I'm trying to add all the thousand, this has got 1,000 elements, this has got 1,000 elements. I want to add them element by element. And that is the operation that we have performed here. And the same operation, I want to create, these are two arrays, NumPy arrays, which we have. And we are again trying to do the same thing, which is nothing but adding them element by element. So that is what we are performing here. So one advantage which we have seen is the number of operations. Here it is 1,000 operations which are occurring. Here it is a single operation. Other important advantage which we have is nothing but the time which it takes. So let me run this code snippet and show you how much time it takes for us to run these two versions. Okay. As you can see, the pure Python version is taking this amount of time, whereas NumPy has taken lesser amount compared to that of uh, compared to that of Python version. So this is another advantage which it gives. So let's see other advantages apart from vectorization and timing. Let's see what are the other advantages which NumPy provides us. Okay. So why NumPy when we have lists? First, we have already seen performance and vectorization. Performance in terms of time I have shown you. Also, the amount of size that NumPy data structures takes is also less. Also, in Python, like if you want to use some mathematical function, like if you want to perform, let's suppose square root or something, you will have to write the functions all by yourself, like define the functions and use them later on. But what happens with NumPy is that all these functionalities are directly available in the form of very optimized functions. Even in the way these functions run, they are like written in optimized codes. So these are the four advantages that we have when we use NumPy arrays as compared to that of lists. So that's about why do we need NumPy arrays when we have Python lists. Okay. So let's go a little more forward. So now what I'm trying to do is show you different ways in which you can create NumPy arrays and play around with them. Okay. So here mainly I have taken two variables called heights and weights, and I have manipulated them throughout this particular worksheet. Okay, so here I have created a list called heights, and it has these numbers. So what is the number of? There are about 6 elements in this, right? So I try to type of heights tells us which class it belongs to, which is list. Then, so this is the first way. Here I'm trying to tell you about the first way in which you can create a NumPy array. So for you to create a NumPy array, for you need to use this small syntax np.array of. This is nothing but a list item. So if I want to create another list, like another NumPy array, let me name it as uh, y1 is equal to np dot array of, I have to be using a list inside, like 2, 3, 4, 5. So this should right now this should give you a few questions, like why are we using only same data type and all that. Let's go forward and we'll understand. So whenever you want to, this is the first way in which you want to create NumPy arrays, wherein first you use np.array, and this is being, and a list is being passed to this particular function. Okay, so let me even print this y1 as well. Okay, now let me run this code snippet. So here first I have created a list called heights, then I have converted it into from that particular list called heights I have created another NumPy array called heights np, and I have printed this heights np here. See this. This also looks very similar to that of list. This is actually a NumPy array, as you can see by the type function. This is a NumPy ND array, but still it is also looking very similar to that of list. Going forward, we'll understand how it looks in a different way as well. Now, I showed you how to create a single dimensional. This is a single dimensional object itself. So let's try to create a two-dimensional NumPy array. Okay. So um, here what I'm trying to do is there are about 4 elements in each list, and each there are about 6 lists like that. And so this is nothing but, like, this has 4 columns and 6 rows. This is like a 6 by 4 matrix. Let's try to print and see what it is. And also here I'm trying to print something called as weights.dtype. I'll tell you what dtype is. But before we even discuss about it, let's see what this code snippet gives us as output. Okay. So first I try to print out this weights.dtype, and it says that it is int32. That means these numbers are integers which take about 32 bits. This is an int32 data type. So this is an integer data type. And when I printed out this weights, this is how it looked. Is it not looking like a matrix? It has 1, 2, 3, 4, 5, 6 rows and 4 columns, right? So this is a 6 by 4 matrix in our regular understanding. Also, this is a two-dimensional NumPy array. Okay, so here This two-dimensional NumPy array, we can even create a three-dimensional NumPy array out of it. We'll discuss more about this reshape going forward, but I just want to show that any NumPy array can be of any dimensions, can be converted to any other dimensions as well, given that the size does not change. Let's understand more about it. Here I'm uncommenting this, and let's see. So when what I try to do here, what is the number of elements which we have when it is 6 rows and 4 columns? 24 elements in this weights RG, which I created as a new weights, new NumPy array. Here also I have 24 into 1, 24 elements itself, but it is rearranged in a different format. And it is a three-dimensional object. So whenever you want to find out dimensions in NumPy array, just try to count these first, the number of brackets that you have in the beginning itself. Usually, when you deal with high dimensional NumPy array objects, we usually get confused a lot with the number of dimensions. So that's why this helps you as a technique to get that. Okay, so now we understood how to create a single dimensional NumPy array and a two-dimensional and a three-dimensional as well, right? Now, let me try to, till now we have only dealt with numbers. Now let me try to do something with strings and character data type. So A, B, C, D are character data types, right? So I'm removing this. You can see that the D type tells that it is a U1, which corresponds to characters. So we could print this. This makes sense because we have already seen that arrays can have only single data type. So this is all a single data type. So this accepted. Now, what if I add something like 34, 56 here? So when I add these numbers, what happens is, let's try to run and see whether it accepts it or not, or we will get any kind of an error or not. Let's see. So what happened is, even these integers, first of all, we didn't get any error, and later on, even these integers have been converted into strings itself. So that is, as we have been emphasizing this very important thing, that all the data types of all the elements in a NumPy array should be same. So if we are giving different data types, it gets converted into a lesser data type. Okay.
Yeah.
Now, so here I just this is some change, right? With respect to Python list, we can have different data types, string 1 to 3.5. These are different data types itself. That is not possible with NumPy arrays. Why is that not possible? Because like we are performing lot of mathematical computations and lot of scientific computations. So for that, if we have different data types, obviously it is going to create problems, right? So let me tell you. Here I have iris. All of these are numbers. Let me make something, one among these as a string. I'll make it as a string, like I'll add something like hj something. What happens is, we cannot use this for the mathematical computation, right? We cannot do any math on this. That's why it is important that we have a single data type.
Right. Gayatri, one quick thing. I think people still have some questions on what is, I mean, like, they're slightly confused about the dimensions. If you can probably, like, summarize a bit on that. We just
Okay.
got a chat comment. And also someone is asking to be slightly slow. I think, like, if you can, yeah, that is one more thing. Yeah, these are the two things I thought I would tell you. Yeah.
Okay, sure. So about the dimensions, we are anyways going to deal with it in the next attributes itself. Yeah, I'll make it little more slower.
Yeah, perfect.
So now that we have created, just that you understood how to create NumPy array of three different types, right? One for single dimension, two dimensions, and also how to create NumPy arrays of different data types like strings we have seen. Now, let us try to understand more about what are the different attributes that we have. Okay, so these NumPy arrays which we are creating at the end, they are called as ND arrays. ND arrays, where N refers to the N is N, and D refers to dimension. So this object which we are referring is nothing but ND array has got few attributes, of which the first important one is dimension, second is shape, third is size, fourth is D type, and fifth is strides. So let's try to understand what these are slowly. Okay. So already we have seen that ND array object is a multi-dimensional object which can only take a single data type. We could see that it can be a string type or numeric or integer or any different data, but a single type. If we make a mixture of strings and numbers, all of them would be converted to strings. Now let us try to understand more about the dimensions. Okay. So before that, now let me tell you. Here I have these three columns, right? So if I so this has about, let's suppose I don't have this column itself, then this has about three columns and 150 uh, data instances. So it is like a 150 by 3 matrix, right? So can we visualize a 150 by 3 matrix with our naked eye? Yes, we can definitely do that, right? We can definitely view, as we have already seen before, uh, here in the matrices area, where I try to show this. This is nothing but the 2D matrix that we are creating, right? So now now let me add this particular, like, okay. So these when we have this three-dimensional object, like when we have three columns and 150 instances, which is nothing but 150 by 3, that is this is something which we are able to view. Now, let me explain it more clearly. So a vector is nothing but a single line, which which is nothing but a sequence of numbers. When it is like, when we want it in a matrix, it is nothing but a square or a rectangle type of a numerical arrangement. Now we can even make this numerical arrangement, like for this matrix, we can add a depth factor and we can view that as well. Like we can create numbers, like we can, let me place few numbers here in an order. And I mean, we can even view a three-dimensional numerical arrangement as well with our naked eye. But what happens, like when we have more number of dimensions, in the sense more number of attributes? Let's suppose you have got, okay, employee data. We have employee data. So what are the attributes which could be present for an employee data? The name of the person. I'm taking as a different data types itself, not a single numerical data type. In a real world scenario, we have got an employee data set. What all it could have? Name, ID, name of the employee, ID of the employee, designation, what is the salary of that particular person. So these are the different columns that we have. So when we take a simple employee data set itself, what are the number of attributes which we can get? Just by thinking, we can get about 10, right? So like this, when we take, let's suppose we want to understand about a particular object in Amazon, then how many number of attributes could it have? So that attributes is nothing but, which I'm referring to as dimensions. Dimension is nothing but which is trying to tell us um, what is the level at which we can manipulate the data set. Like what is the depth, what is the level at which we can organize the elements and uh, visualize them. So, okay, once I explain more about shape, you might understand the difference between dimensions. Okay. Let me create a.
Gayatri, one quick thing before we proceed to the next section, right? We have
Yeah.
some questions, questions on YouTube. Probably, Gunika, can you please unmute yourself and ask those? It's
Yeah.
about the code. Yeah, go ahead.
Okay, so we have a few questions. First of all was, please explain the fourth line of code, which was the reshape one. Can you explain the reshape function, please?
Okay. Yeah. Okay. So reshape, this helps us in like, what is the shape of this particular weights? Let me print that. So what is the shape of it? It is 6 by 4, right? So now using this reshape function, I can convert it into any other shapes. So before we even talk about adding a new, here I added a new dimension. Here you can see that it is uh, the number of elements in this shape tuple is nothing but the number of dimensions. This is like a rule which we can remember. So here we have 6, 4, that is, it is two-dimensional object. before we even add the third dimension, let me put it this way. So I want to convert it into a different dimensions. So 8, 3. Okay. Now, what this reshape does is it helps us in changing the shape of the given NumPy array. So 8 into 3. Now, if I print this weight RG, it has been converted this way.
Yeah, I think that's a nice way of putting
that's a good
things.
explanation.
Yeah, great.
Okay, then we have how do we say if an array is two-dimensional or three-dimensional?
Yeah, that's what I'm trying to explain here. So whenever like a blind rule is that just try to count the number of brackets that you have in the beginning. That gives you the number of dimensions. Also, the number of dimensions is nothing but the number of entities in the shape tuple. This is a tuple, right? The shape is a tuple. So it has two entities, so it is a two-dimensional object. So if I create 831, and again I'll print this print. Okay. So here you can see 831, right? Which is for the reshaped one. So it has three entities, it is three-dimensional.
Yeah, cool.
Yeah.
So another user is asking the difference between type and D-type.
Okay. Type is something which we use in Python. D-type is a function which is associated with NumPy library.
And they perform the same task.
Yeah, yes.
Cool. Okay, what is U1 and U2?
There are like there are the classes which are associated with strings itself. Like for integer, how we are able to see is int 32, int 64. Give me 1 minute, I'll open that. So these U1 and U2 are also related to the string type itself, just like int 32 and 64. Yeah.
Okay, so I guess that's all for the previous code block. I'll let you know when we have more questions.
Yeah, sure. Thank you.
Okay.
So I think a little bit now, before we go forward, I want to print this weights again so that you have a look at it. Here we try to reshape it, but I preserved the original one as well. So this is our original weights two-dimensional NumPy array, right? So in this, so as I've been telling you, it is two-dimensional. It already NDIM, what it does is it tries to give us the number of dimensions. So if my weights, like if I print for weights RG, let's suppose, okay, we have transformed it, right? It okay. So for weights RG, okay, 1 minute. If I print the number of dimensions of weights RG, as you can see it here, which we transformed, it is, as I told, the number of entities in this shape tuple is 3. That's why it shows this NDIM as 3. The shape, and I'm using the original weights itself so that we don't get confused throughout the course. So shape is returning to us because it has 6 rows and 4 columns, it is 6 by 4. Size, what is this size attribute helps us understand is the total number of elements in that ND array object. So if you have 6 rows, 5 columns, then 6 into 5, 30 elements would be there. Size would return as 30. What is D type? As we have already discussed, it tells us about the data type. So whether it is integer or string or character, that's what it is. Strides, this is little bit of machine dependent, and it tells us what is the number of elements that it takes for us to go to the next row. So this is like, it depends on, I mean, it depends upon the byte size and the machine size as well. So this varies, this value varies from machine to machine. So even before we, since we have been dealing with weights itself, which is a two-dimensional, let's see what our heights NP refers, which we have created before. It refers this NDIM as 1 because the dimension of it is 1. Okay. So now we understood what is shape, what is size, what is dimension. At least we could make little sense out of it, right? Now I want to tell which we have tried to do it earlier. Let's try to convert one-dimensional, like two-dimensional object into a three-dimensional object or a four-dimensional object. Like, to always remember, if I'm referring to a two-dimensional object, it is like a matrix. If I'm referring to a three-dimensional object, it is like a box in which the numbers have been organized in an order such that it has length, breadth, and width as well, length, breadth, and depth as well. So let's try to convert how to change the dimensions. So be very clear that shape refers to the number of elements across each dimension. Dimension refers to the number of brackets. That's it. With the help of these number of brackets, you can tell what is the number of dimensions that you have. Okay. So this we have discussed all of these in an order. So just have a glance at it before we go further. Okay. So now let us see. Before we move to some miscellaneous NumPy arrays itself, we will try to do how to convert from one dimension to another dimension. So I have weights.
One quick question. I'm sorry, Gayatri. So we have some questions on strides. Four people asked. So basically, can you explain strides again? How did the answer 16,4 come? I mean, like,
Yeah. Okay.
why in 32 and not just int? So these are the two questions which are repeatedly asked. Yeah.
Okay. So in 32, because I was telling you, right, it is the about of the bits that it is taking on this particular system. Like my is a 32-bit system, it is taking 32 bits to represent that particular integer. So that is int 32. It can go to int 64 as well.
Okay.
Yeah. With respect to strides, give me 1 minute. I'll try to take an example and explain much better. These values, like, yeah, are machine dependent. That's the issue. So what I'm trying to do here is just create an NumPy array, which is 3 by 3, two-dimensional array. Sorry. So as you see this, what is, okay. So what is the number of each element here is taking about 4 bytes for me. Okay. So this is 1, 2, 3, 4 into 3 is 12 bytes. After 12 bytes, I'm able to reach to the next row. So I'll print this 2D array. So what is each element here is taking about 4 bytes, right? So what is the total number of bytes till now? 12 bytes. So after 12 bytes, what I'm trying to tell is what is the next, at which point I can reach to the second row? That is the question. Strides always tells us. So after 12 bytes, at fourth element, I can reach to the second row. That's what it is telling. So now here, what is it telling? Let me print this weights again. There are about 4 elements. Each integer is taking about 4 bytes. That is 16 bytes. So after 16 byte at fourth position, like it starts at 0. Arrays here start at 0, 1, 2, 3, 4. So at the fourth position and after 16 bytes, we are reaching the second row. That is what it is telling. Am I making sense?
Yeah, I think it addresses, but if someone has any question, maybe I think we have Mahika and Darshan, no, not Darshan, Aditi. Were you able to understand? Yeah, it's clear now. Okay, great, perfect, thanks. Yeah.
So now, okay, so even if we take it further, I'll create a 3D array as well so that it will be more clearer. So me name it.
I think Gayatri, I mean, like, they're very happy with that. Like, they say yes. I mean, like, it makes sense. And to me, it doesn't explain why it is 4 in both cases. Okay. So there is one question to me. It doesn't explain why it is 4 in both the cases. I don't know if I'm mistaken.
Oh yeah, I think 4 is referring to the number of bytes. I will definitely look into the syntax of this, and I'll try to explain what this 4 is referring to. As far as I know, it is referring to the number of bytes that it is taking for each element itself.
Yeah.
Yeah. So here, why I'm thinking to create a new array is a 3-dimensional array is that so that I can convert it into a high dimensional space. So let me name it x3. So this even helps you out understand how to create a 3-dimensional array. Yeah. So here what I try to do is let me print as the number of dimensions as I told is the first 3 brackets, it's 3. Now let me print the shape of this x3 as well. So it has 2, 2 and 3. So what am I trying to do is, so in this 3-dimensional space, so there are about each of this in the inside in the like the bracket which is mostly like totally inside, it has about 3 elements, right? 2, 3, 4. It has about 3 elements, 5, 6, 7. So that is what is being referred by this 3. And what is 2 referring to is the number of elements which are present in the second bracket from inside. What are the number of elements which are present in the second bracket? Number of elements is 2, right? This bracket and this. That is what is referred here. Sorry. Now when we come to this final bracket from inside, what is the total number of elements present? Again, it is only 2, this one and this one, right? So that's why it is referring to 2, 2, 3. So now you should be able to tell what is the size of this particular x3 as well, which is nothing but 4 times 3 is 12, right? So now let me convert this. So this has 12 elements. Now let me change the dimensions now. Okay. So please remember x3 dimensions is 3. Now I want to create x2 out of it. For that, I am trying to reshape it in such a way that I'll have 12 elements. You cannot reduce the number of elements or do anything like that when you're reshaping. You should have the same elements. So now what I'll try to do is I'll make it 4 by 3 matrix. As you can see, I could convert all these, I could convert them into a 2-dimensional space. So that is what I'm trying to explain here. So here my weights was originally a 6 by 4 matrix, right? So that I can convert it to a 3-dimensional space just by adding one column, like just by adding one bracket, I can make it into a 6 by 4 by 1. So that's how I made this. I can even convert this into another dimension. Again, I can put it 1. Why am I using 1? So that I don't change the number of elements here. Okay. Also, now I will try to convert this weights. I'll make it as 4D. Weights 4D, I will change into another size totally. Let me take it as 24 elements as I have to get. 2, 3, 2, which is 12, and again 2. Let me print this. So this is the amount of, this is how the array has been formulated. So always like don't, that's why I'm telling this is the best way to understand the number of dimensions when you're directly looking into the NumPy array itself is to count these number of brackets in the beginning. So this is how, like, our weights was originally, 1 minute. I want to recreate I just want to save my weights as such. I don't want to change it because we are going to use it throughout. So here, first I'll print this weights 4D. Sorry, earlier it didn't print this value. Now, again, I will even print our original weights. So you can see that what have we created is, as already start from always start from the most inside bracket, which tells us about the total number of elements in the most inside bracket, which is 2, right? And then take this particular bracket and see what is the number of elements which it has. So this bracket is being closed at here, right? This bracket is being closed here. That is again referring to 2 elements, so that's why it is 2. This third bracket from inside has about 3 elements. That is what it is here. And the final bracket has about 2 elements. This is the first list, and this is the second list. My original weights is as such. So am I clear till here?
Yes, I think so. Yeah. Yes. Yeah.
Okay. So now we'll talk about some miscellaneous NumPy arrays. So these are like, it's only syntaxes that you have to look into. Like we have very good, these miscellaneous arrays usually help us in, like, when you're pre-processing data, sometimes you might want to append zeros. Sometimes you want to pad zeros for your already available data set, or we call it, like, in deep learning, we call it as a tensor. So that's the application. Like in tensors, you might want to pad some zeros. So for all those kind of operations, these miscellaneous functions could be helpful. Okay. So so these are the miscellaneous NumPy arrays which we'll be looking at: zeros, arrange, linspace, and full. Okay. First of all, what zeros does is very simple syntax. All that you have to do is give the shape. We have been dealing with the shape. These are the attributes, right? D type, which is nothing but the type, and order. Order is here, I want to make it as a column wise. That's why I have referred to as C. Okay. And I can even actually ignore this part as well. It takes the default value also. So default is nothing but the column wise. I don't remember what we use for row wise. So this is how we can create the NumPy rows, np.zeros. Now if I give another, so if I add another number here, what does that mean? I have converted this, like now I'm referring to 3-dimensional zeros that I want to create. See this? So I could create a 3-dimensional object, number of brackets, simple, right? Now let's talk about something really interesting and very useful. So here, arrange, this is what is being used. So this helps us in creating NumPy arrays in an ordered fashion. Like I want to start it at 100, like I want to start at 100 and stop at 1000. My each step size is 100 and D type is int32. So what am I referring to? I want to create an even spaced NumPy arrays, like even space, because with a step size of about 100, between 100 and 1000, I want to get the numbers. For that, I use this. So what is it referring to? 100, 200, 300, 400, 500. So it does not include this 1000. It is stopping at 900 itself. Okay. So this np.arrange we can use to create like any number of, like we can create like an ordered fashion. This where do we use this? Like when we are creating some plots in matplotlib, so we want to create an x-axis. For that, like usually our x-axis is at an even space, right? Like 1 2 3 or 100 200 300. So for that we can use this np.arrange. Now even without mentioning all of this, I'll just mention 150, a random number. Then what it does is, it default value of start is 0. It takes it as 0. Default value of stop is 150. That's why it is still 149. It doesn't include 150 as I told. And it takes this default value of step size to be 1. That's why I got this. now as we understand linspace, we'll better understand about arrange much better. Okay, so again linspace is also same.
Gayatri, one
Yeah.
quick thing. Can you zoom in your screen a bit more so that, like,
Oh,
yeah,
okay.
yeah, perfect. Yeah.
So um, so that's how we have created np.arrange. So here we have start, stop, step size. So for the default values, just I'm again giving a refresh. Default values are start 0, step size is 1. So that's why without mentioning anything, I could directly just mention the stop value, which is nothing but 150, and it has taken out to be these values. This has returned this. Always remember, it does not include the final element which we have taken up. Okay. Now let's talk about linspace. Then it makes more sense about arrange. So here also we have a start, we have stop, and we will give number as 30. So what we mean by that is between 10 and 50, divide that space into 30 elements. Like if you count this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. So this has about 30 elements, but they are arranged in a like uh, with evenly spacing between them. Excuse me. Yeah, with even space between them, but they are divided into 30 parts. Here we are mentioning the step size, like what is the size between each part, size between each part. Here we are mentioning the like the number itself. We are not mentioning the size. So it tries to find out some point so that it can create into a space. And here another important difference between arrange and linspace is linspace includes the final element as well. That the stop level it will also be included. So am I clear till here?
Yes, yes, yeah. People are saying
There is
yes.
just one doubt that has been common. It's about what is the use of changing the dimensions, like increasing or decreasing the dimensions.
Okay. Um, Give me a minute. So usually, what happens is we will have different NumPy arrays. Like in our data sets, we will have. Let's suppose I have two different data sets which I have to be using, and I need to transform them. So when I have a data set which is about which is with 100 dimensions. Okay, so can I view that 100 dimensional NumPy array with my naked eye? I won't be able to do that. So for that, I might want to convert those 100 dimensions into a three-dimensional space. Now, how do we do it? There is a whole lot of concept called PCA, TSNE, which we would be learning further. So these techniques help us in converting those higher dimensional spaces into lower dimensional spaces to view them. But what happens sometimes we might want to project lower dimensional spaces into a high dimensional spaces also. Like when we are doing this data pre-processing in a real world scenario, we will want to convert dimensions for sure. So that's where we will be using this change of dimensions.
Okay, that clears it.
Yeah.
Yeah,
Thank
thank
you.
you. So another simple miscellaneous NumPy arrays, just np.full. It fills the total here. When I'm putting it in a tuple, this is nothing but shape. So 5 6 is nothing but the shape, and I want about 30 elements to be placed in a 5 rows and 6 columns with all the elements to be 4. So why do we need this again? So we might want to fill, as I already told, padding as an important concept. Usually in neural networks and deep learning, in sequence to sequence learning, just I'm giving you a word so that it can create some interest in you. So this sequence to sequence learning helps us is what we use in speech recognition. So that's where we use. So when we are doing that kind of modeling using neural networks, we will be mostly doing padding. So for all those techniques, we can use these functions. Okay, so let's go further a little and understand resize, reshape, flatten, ravel. So we have already dealt a lot with reshape. So let's understand the rest of them as well. Okay. Um, so even before we look at this theory, I think it's let's go with the worksheet itself. So here we already know the what is the shape of weights. which is 6 by 4, right? So now I want to reshape it into another, which we have already been seeing for a long time, 2, 3, 2, 4, let's take it that way. Then this is how we could reshape. Okay, always I'm adding a dimension. Let me not do it. Instead of 6, 4, I'll take 8, 3, the same dimension itself. So the number of brackets is 2. That's why we are doing it in the same dimensional space, but we are just reshaping it. So reshaping also again, because we will have in the data set we'll have different like when we will be needing lot of dot products and these kind of operations between the data frames which we'll be learning in pandas. So for that dot products and all that, we need that compatibility of shapes. That's why we use a lot of this reshape function. Now I have this heights NP, right? Now I want to resize it to what is the size of heights NP? 1, 2, 3, 4, 5, 6, right? So, but I want to use like resize it into 6, 4. So I cannot do that because the number of always like, wait, give me 1 minute. Okay. I'm creating a new array. Simple 2-dimensional array is what I want to create. So before let's talk about the shape of it. X4. So it has about 2 rows and 3 columns. Let me print this. It has about 2 rows and 3 columns, right? So and now I want to resize it. So what is the size of this? 6 elements. So size of it is 6. So I can resize it to another size itself. Okay. Okay. So what I'll do is like I'll send this when I'm sharing the worksheet itself. I'll send you this particular resize like changed code itself. So what it does, let's try to understand at least that. So here we have about 6 elements. So using resize, if I want to uh, create another row, like I want to convert it into it is 2 by 3, right? I can make it 3 by 3 as well. Like I can create another row also. All that it because the total number of elements is only 6, but now I'm trying to add like create a array of 9, size 9. Then it does is it adds zeros to it. So that's what resize does. So resize helps us in adding padding zeros to the already existing numpy array if ever we want to change the size of it. So I think I just have to look into the syntax of this once again. I'll do that change and give it to you. Like if you have any questions, you can ask me.
Yeah, I think rechanged version should help. I mean, like, we understand sometimes, like, there might be some errors with the machine and bunch of other things. So that should be fine. Yeah.
Now we understood about the reshape, right? I'm not changing the original weights. So again, I'll make it as like weight 1. So this is how we could reshape. That's what is understood. Now let's talk about flattening. So what is the number of elements? Again, it is our original weights was 6 by 4. Now it has 24 elements. What if I want to like put them all in a single array itself? So for that, I can use weights dot flatten. So what it does, it converts all the 24 elements have been put in, because as I already told, the bracket indicates the dimension. It is a single dimensional object. So a 2-dimensional object has been converted into a 1-dimensional object with the help of flattening. Now, what does Ravel do? Ravel also does similar kind of an operation. So you can either use flatten or Ravel for the same kind of operation of flattening the arrays. So again, um, the flattening also helps us out in many a times our output object, like whenever you are predicting something in a regression problem, you will be predicting y. So that y you might want to give it as a single vector in a linear regression kind of a problem. Then you might need to use this flatten and Ravel. If they are of different shapes, you can convert it into a single vector and use them. So am I clear till here?
Yes, you're clear.
Yeah.
We have a few questions if we can take it in between.
Yeah, sure.
Yeah, so some students were asking if you could repeat linspace and how it gives output and float values.
Okay. Okay. Any more do we have, or is it only this?
Yeah. So one was a continuation of the previous one about the applications of changing the dimensions. If that can we say it is used to convert from long form data to wide form data.
Wrong form data to right form data,
Like
right?
long form to wide form.
Wide. Okay, I did not get what long and wide are.
Yeah. It's probably just a way of saying and understanding.
Okay, like um, from a vector to that of a matrix, like that. Is that what you're
Yeah,
telling?
Yeah. Yeah.
basically changing the height and width.
Yeah.
Okay, yeah. Uh, so let's talk about linspace. As I already told, it only takes the number of parts, like between 10 and 50. What could be the points where this could be evenly spaced? Like, okay, let me take it as um 0 and 50. I want to convert it into um, yeah, 30 objects. Let's take. So what could be like, there are about they like the numbers which if we take between start and stop, there are about 50 numbers, right? But we want to we do not want 50 numbers, but we want to divide that space, like that linear algebraic space between 0 and 15 to only 30 parts. Then what could be the numbers? Like even spacing, obviously we will be getting in a real number scenario, it is going to be a float number itself, right? So that kind of a division is what is giving us in these kind of float values. And regarding conversion from dimensions, yes, it is not only about converting from a like long to wide, or as I already told, you might want to convert from a high, like I told that let's take if wide refers to as more number of dimensions. I already told if we have like 100 dimensions and we want to view it in our 2-dimensional space, we cannot do it. That's why we will convert into a low dimensional space. It's not only about long or wide, it's about uh, converting from one space to that of another space.
Cool.
Did I? Yeah. So shall we go forward?
Yes, yeah, we can go forward. And probably like what we can do is maybe like in 5 minutes or 10 minutes we can quickly take the questions, and then probably like we can start the Q&A, or
Yeah,
whatever.
sure.
Yeah, okay, yeah, great.
So I'll try to take this little indexing is something which we know, right? So even in like in the other programming languages, array is nothing but sequence of numbers. That is clear. So we might want to find out what is the element at first index, second index, third index, fourth index, like that. So indexing helps us understand with that what is the element at a particular index. So before that, let me again print for this heights for you, heights entry for you. So now Always remember indexing in NumPy array starts at 0. So this is 0th element, this is first element, second element, third element, fourth element, and fifth element. So now I want to, so if you want to access a particular element, just write heights NP with this closed brackets. You can have to just close parenthesis, you just have to give the number. Like if I refer to 4, it refers to as 0, 1, 2, 3, 4. 189 is what it should refer. Let's see. So it is giving 189. Because it is a two-dimensional space, like for weights, it is a two-dimensional space. So now I want to refer to the third index in terms of rows, third index in terms of columns. So let's see, 0, 1, 2, 3. This is the column that I'm referring to. Again, 0, 1, 2, 3. This is the row that I'm referring to. So as the junction of that particular point is nothing but 59. That's why we're getting is 59. So if I can even go and get this also, like 0, 1, 2, this is what I would like. So 0, 1, 2, 67, and 0, 1, 2, 3. So it should give us 70. Let's see this. So this is referring to the row index. Go down and find out. This is referring to the column index. Go in this direction and find out. So that's how we can index a particular element. So how does indexing help us? So when we are not using vectorization, we just want to loop through this particular NumPy array, then we can use this indexing. Also, like if we want to find out an element just in order of one time, then also we will be using this indexing. Now we understood what indexing is. Let's try to cut our particular NumPy array. Let me know if I'm going a little fast. There are a few things that we have to cover. So here, this heights NP is a 6 element. It has got 6 element in a one-dimensional space. Now, when I give this 2, what I meant is that I want to get only the first 2 elements. Like only till this. So tell me, this is 0, 1, 2. This is the second index. So when I'm referring to 2, I want to get elements before the second index. That if I want to get that kind of a slicing, if I want to do that kind of a slicing, I'll use this. Now, if I refer to, it starts from 2, like always remember, this does not include, like this is 0, 1, 2. When I'm using this 2, that second index element will not be included. But when I am starting from, I want to find out from the second index element, like 0, 1, 2, I want to get the elements from 171 to 178, then I'll have to include this 2 as well. So that's why here, so if I want to use return first 2 elements, I should use 2. If I want to return to first 3 elements, then I'll have to use 3. But it does not include the third index element. Why is it third index? It is actually fourth element, but according to NumPy, it is third indexed element because it starts from 0. Now, if I want to include, like if I want to get the elements from the third index itself, so it even includes, like when we are from the beginning, it includes that particular third index element also. But if we want only till that element, that will not be included. The indexed element will not be included. So now that we understood from starting and from the ending, now we can even find out how to get a part of it. So from this heights NP, I want to get 2 and 4. Let's count. Let's see what will be included. 0, 1, 2. So this should be included 179, 3, 4. But we know that if it is in the later part, we should not include. That's why this 189 is not included, but only these 2 elements are included. That's why it is 171 and 180 that is being referred. Please remember that the indexed element will not be included if it is an endpoint. So the similar kind of slicing, because we are doing a two-dimensional slicing, I'm using 2 columns here. Sorry. So similar kind of slicing can be done for two-dimensional matrix also, like two-dimensional NP array also. So weights or is nothing but we have reshaped it into 4 by 6, right? At 6 by 4, we have reshaped into 4 by 6. For the same weights or I'm trying to slice it. The same size of these, like you can play around and slice it in various ways and see how you can get that. I removed this weights. Give me 1 minute. Wait. Okay, so right now my weights is it has become, okay, 1 minute. Again, I got the original value. So now that I sliced, I could get a single dimensional object, two-dimensional object as well. So just play around with this. You will find out in what ways you can slice it. Any questions still here?
No, I don't think we have any questions in this.
Okay. These arithmetic and logical operations are simpler. We can take them little fast. So let's see. So I have created my, apart from the previous heights NP array which we have, I have created another one-dimensional array just to keep it ready for this. And my weights is already there. I already reshaped it and made it ready. So what I want to do is do element-wise addition, 165 plus 165, 170 plus 175. All that you need to do is just use this add. We did it in the beginning also, right? In the timing version also. Also, apart from doing that, we have certain functions like np add, np.add, np.subtract, np.multiply, np.sin, np.cos. So these kind of functions are available. Before we talk about sine and cos, so these kind of additions, which are like direct additions, can also be done here. Also, you can subtract directly also. That also can be done. So these kind of addition, subtraction can be done with the functions that we have. Here I have given the list. So we can perform all these operations like arithmetic operations, tangent functions can be applied, exponential functions, square root functions. You can even compare NumPy objects, and you can even apply logical operations. So let's try to see how we can do this comparison and logical operations also. So NumPy np.multiply, again we can take the two NP arrays and multiply them. More about matrix multiplication, like two-dimensional also we are going to deal after this section. We'll understand that. Now, what is np.sign? For the given numbers, it just tries to apply the sign function. So I'll take this also once. So sign is np.sign of height 2. So as I applied, so it is taking these two values as radians, 165, 175 as radians, and it is applying the sign function to it. Because it is a unary operation, we have taken only one element. Okay. So these are all the mathematical functions which we can apply. Now let us see the logical operations. So here, what did I do? I created np.arrange of 5. I did not mention start. I did not mention the step size. As I already told, the start will be 0. Step size is equal to 1. So I have created an array 1, 0, 1, 2, 3, 4. For that, what I'm trying to do is I'm trying to return those elements which are less than 1. Like logic, what is a logical or and operation? Or operation is that any one of the operation can be occurring. Like even if one of the operations occurs, it returns true. If one of the operations is false, like either if it is true or this is true, it returns true. If this is true and this is false, also it returns true. This is false, this is true, also it returns true. Only if both are false, then we'll be getting false. Okay, so I want elements which are less than 1, and I want elements which are greater than 3. So what are those? 0, 1, and 4. That's why, sorry, less than 1. So that's why it only returns true here, 0. 1 is not less than 1, that's why false. 2 is not less than 1, that's why false. 3 is not less than 1, or 3 is not greater than 3 also, that's why false. X is greater than 3, this operation has been fulfilled, that's why we got it as true. So that is about logical. So we have or and XOR kind of logical operations that also we can do with NumPy. So also here, I'm trying to find out logical and operation also for the same thing. So what is this logical and operation is trying to do is, at the same time, I want X to be in AND operation, both of them should be true, and only then it becomes true. Like if one of them is false, it is false. So can an element be 3 and 4 at a time? Not possible. So that's why none of these will satisfy that kind of a situation. That's why we'll be getting all of them as false. Okay. Now if I change this condition as X is equal to 3 and X is equal to 2, X is greater than 2. So what happens at this particular element? Both the conditions are being satisfied. For OR, simply any one of the condition needs to satisfy. For AND, all the conditions needs to be satisfied. I'll add this. For AND, so that is about logical operations. Now comparison is simple. I just want to find out whether these two are equal. Is X is equal to Y? Very clear, it is not. That's why it has returned false. So these are the different operations which we can perform. So yeah, any questions till now?
No, so far I think yeah, like operators and these things are pretty much clear, I guess, and they have also done it, so should be fine. Yeah.
Yeah. So this is an interesting concept. Rest are going to be again simple. So what is this broadcasting is? So okay. So why did I mention this reshape of 6,1? Let me print. So my heights NP till now is a one-dimensional object, right? Now I converted it into just by adding another reshape whenever in a tuple is a shape. That's what I told. So I converted it into a two-dimensional space. So now my heights is also two-dimensional and my weights is also two-dimensional. Now what I want to do is I want to add this heights NP to that of weights. Like, can I do it? There are only 6 elements here. There are 24 elements here. So can I add something like that? NumPy allows us to do it. How it does is, this is 164. It tries to replicate this particular, what is the total? This has about 6 rows and 4 columns. This has about 6 rows and 1 column. So the same one column will repeat itself 3 more times. Here again 1 time, here 1 time, and here 1 time. And then they can get added. So after it replicates itself, they can get added. So 165 plus 50, 170 plus 78. Again here 165 plus 45, 170 plus 89. So that's how it goes. Let me show you. Just give me a minute. So when I try to add this heights NP to that of weights, as I do it here, we are able to add them. So what is 165 plus 50? 215. 165 is again getting repeated here. 165 plus 45. That is how it is able to replicate. So what is broadcasting is, sometimes we might want to add smaller dimensional, not smaller dimensional, smaller shape elements to that of larger, like the total size of the one NumPy array can be less than that of size of other NumPy array. So if the size of NumPy's arrays don't match, that is, here we have 6 elements, here we have 24 elements, the smaller one will repeat itself so that it can match the size of this particular bigger element. So again, it will also make itself as a 24 element size, and we can add them. So I guess this should be a little interesting, which NumPy provides us. So any question till here?
No, so far. Yeah.
So here I just try to help you with what is the theory behind this NumPy. So sometimes we might want to add something which is larger to something which is slightly smaller. So what happens is the smaller array multiplies itself to perform an operation. Like what happens is the smaller array will replicate itself such that it can match the size of this larger array. And we can perform the further operations like summation or multiplication. Okay. So after this, so this is where our like knowledge on matrices helps us. So we know that matrix can be added, matrix can be multiplied. So how we can do those kind of operations with NumPy is that here I have created a 3 by 3 matrix A, 3 by 3 matrix B. Nothing but a two-dimensional objects, NumPy arrays that I created. So here is my matrix A, here is my matrix B. So I want to perform element-wise multiplication. What is element multiplication? That means I want to multiply 1 into 2, 1 into 0, 8 into 0, 0 into 3, 1 into 4, 9 into 9. So for element-wise multiplication, all that I need to do is just write A into B. So why do we need element kind of a multiplication? Again, when we are in a deep learning context, or in like when we are trying to apply the machine learning algorithms, we might want to just take few elements out of the matrices and multiply them the corresponding like take two matrices and only multiply the corresponding elements. So that's where we will be using this element wise multiplication. And we know what is the conventional matrix product or matrix multiplication. We take a row and multiply with a column. Like if we want to multiply two matrices A and B, we take the first row and multiply with the first column, right? So that can be done with the help of A. This is the symbol that we use. And here it is uh, conventional traditional matrix product, which is also equal to dot product. Of all these operations, we will be using this dot product like so many times while we are applying, particularly in the context of neural networks. We'll be using this dot product a lot of times, because we'll be multiplying vectors with vectors, vectors with matrices, matrices with vectors. So that's why these operations which NumPy is providing us will make the things much simpler for us. Okay, can we take it forward?
Yes. Yeah. I think we can take it forward. Yeah.
So now what I'm trying to do is, apart from np.fill, we have seen, right, np.fill, where we try to fill the particular element. There is something called as np.ones, where it fills all the shape, all this 12 elements by ones. So like that, I created a array, NumPy array A, which is all ones. Now let's talk about this np.random.random. So this is a important module of NumPy array, np.random, which has certain functions like random, randant, rand, normal, random, randant, normal. So these are the functions which it has. So what it does is it creates random numbers. So why do we need this random numbers? Let's see a little. We talked about matrix products like addition, dot product, element-wise multiplication, and multiplication. So let's create random numbers. So what happens usually? We have a data set. It is all random, like the real world numbers or real world data usually follows a normal distribution. Like if you want to give some like food to your brain, just go and learn about this Gaussian normal distribution. This is such an interesting concept. Like in a classroom, if you take the heights of a student, that is going to follow a normal distribution. Like if you want to take even this that is nothing but the bell curve. Like even the ratings that are given in the IT sector, they give it in the form of a bell curve. So real world can be mathematically modeled with the help of Gaussian or normal distribution. So that is all random. The numbers which we have are like very random. So sometimes what happens is, for the already existing data set, like I have this data set, right? For this, I might want to add some other random numbers to it. Why? It depends upon the problem statement. So when I want to do something like that, I can use these functions called rand, randant, normal, and random. So let's see what it does more clearly. So this random.random of what I'm trying to do is, I want to create random numbers of size 4,3 again. So that's what it created here. Then what I try to do is, I just made b is equal to b plus a. This is a Python addition operation, right? So after I have created a with ones, b with random numbers, I added them up, and that's what it is here. So my main focus is to tell you how to create this random numbers of any shape. So now for addition operation, obviously they should be of same size, same shapes, right? You cannot add for different shapes. Now, after I discuss a little more about this, I'll give you some time so that you can ask questions. So here, what is the seed? Seed is something like if I don't have the seed, every time, okay, um, just remember the numbers. This is 0.414, right? Now again, I'll run this. This is 0.66. Now again, I'll run this. This is 0.34. Is it the same number that we are getting? This is so random that it gives different numbers each time. But if you are adding, like for every time you run your code and you're getting a random numbers, will you be able to model it the right way? You cannot do that, right? So that's why we set the seed. So what it does is, as I set the seed to 2, always, like here also I'll set some seed, okay? Like you can take any number, like 45 is what I took. So for that seed, I got this number. Now I'll again run the same thing. Always it is going to be 0.98 only. So the numbers are going to be the same. They are random numbers, but every time you run, you will get the same thing. So that's what seed helps us do. So here what I'm trying to do is, this rand will generate random numbers of like 10 random numbers between 0 and 1. Okay, wait. Between 0 and 1, like it can give any, like 0 and 1, there are infinite numbers, right? Of those numbers, it can give any 10 values. So that's what my values is going to return to me. Now, let's take it little forward. Now, if I tell rand int, it is going to return only one random integer. One random integer between 0 and 10. Okay. So again, when I talk about normal, it is going to create 100 numbers. Like it is going to return to me. Excuse me. Yeah. So let me run this. So even this random.normal, what it does is, it tries to return one particular number from 0 to 100. Some number, it is a real valued number that it returns. Normal is returning a real valued number. Randint is returning an integer value to us. So why are we using all this random and all? As I already told, we might want to add some randomness into our data set. So then we can use these functions. So any questions till now?
No, I guess we don't have.
Yeah,
Right
so
now.
one thing is, like, people are asking what difference does seed make. So it is to reproduce the same kind of results again and again, right?
Yes.
That's what, yeah. So reproducibility is the major factor that we would have when we use seed. Mahika, I hope, like, you I mean, your query was addressed. Yeah, that's pretty much about it, I guess. Yeah, go on.
So now
Yeah.
that we understood about the randomness, so let's try to, like, we have two different, let's suppose we have two different NumPy arrays. We might want to stack them, append them. So in lists also you can do that, right? You can append the list, you can extend them. So let's try to do how we can do that with the help of NumPy. What does NumPy give us so that we can perform the same kind of operation? So here I created my array with these elements, and here I created an again x and y are x is another NumPy array. So what I want to do is just append them, append my array with that of NP x. So let's see what it returns. So y is nothing but, in a row wise, first it has put all the my array elements, and then it has put all the x elements. So similar kind of an operation can be done with concatenate. Here also what it does, it just places them in an order. So we get it's 12, 34, 54, 65, followed by 1, 4, 5, 6. So same kind of an, so like till now we have seen that we can place them in a single row. Now if we want to create them and stack them in a vertical fashion, like stack them in row wise, then what we can do is use this np.vstack, like give the name of your first array which you want it in the first row, and the array which you want it in the second row. So when you do that, stack row wise, it is what it is going to return to us. 12, 34, 54, 65, 1, 4, 5, 6, and 2 rows. This is a two-dimensional space, right? Now, then you want to stack them horizontally. Okay, wait. So till now, what we have seen, two ways in which using append and concatenate, in which we can join them, join the two arrays. Next, to join them row-wise, like create rows. Now let's see how to join them horizontally. Okay. For that, what we use is np.hstack. Again, use the names of the arrays which you want to use. So when you want to stack them horizontally, again, it is going to require something very similar to that of concatenation and append itself. Okay. So there are mainly three stacking operations: vstack, horizontal, and as well as column stack. Now let us see how we can stack them column wise. Just give the names. It is just column np.column stack, my array, and x. So the first element, which is nothing but my array, is placed in the first column, and the second array, which is nothing but x, that has been placed in the second column. So here we could stack them column wise. Here we could stack them row wise. Here we could stack them in a single row or a single horizontal fashion, like concatenation. So here there is a column wise repeat, which also returns very much like column wise repeat is also an operation where you can place them in columns, the given arrays in columns. Is it clear?
Yes, I guess. I think we don't have any questions. Yep, yeah, we are getting yeses. So go ahead. And now comes the interesting part.
Yeah. This part of a code can be a little bit confusing. You will understand this once you learn the matplotlib part. So I'm just trying to help you like give that flavor to the to this whole discussion, that it's not only about numbers always. You can view them in the form of some beautiful plots as well. So this part of the code, as I told, takes little time for you to understand. I'll just try to tell you. So in this, I have set the random state, which is like, again, helps similar to that of seeding. Then I have stacked them horizontally to create I have this particular part helps me in creating the x-axis, and this helps me creating in the y-axis. Then using this hist function, I have created this histogram. So about this hist function we will learn in matplotlib session. So what I want to tell you is, using this NumPy arrays, you can further, when you're going through matplotlib and seaborn kind of libraries where you want to create beautiful visualizations, you can use the NumPy functions as well. There are another function here which we are trying to see is, we are trying to create a mesh grid, like taking all the points. What is it doing? np.arrange from -5 to that of 5 with a space of about 0.01. We are trying to create a mesh grid, and that's what it is here. Just don't worry much about this part. You will definitely understand more of this in the coming sessions. Okay.
Yeah, totally agreed.
Yeah. And now finally, like, so much we have done with the NumPy arrays. So I have after we have done so much, the most important part of data science is reproducibility of the total pipeline as code, and as well as the data itself. Like, once you have used the data, you cannot just throw it away and get a new data. So that data has to be stored. So all this NumPy is allowing us to manipulate data. So initially I gave you a data set, you performed all this, and you got a new data set. So you have to save that particular data set, right? So for that, you can save a NumPy array object with the help of into a text file like this. So first I created an X called np.arrange, again 0 and 5 with a size of about step size of about 1, and here it is a float numbers. Okay, then I just printed out so that you can see. This can be saved using a function called np.save.txt. This is the name of the file where you want to save this. In the same directory where you're creating, it is getting saved. This is the NumPy object which you want to save, and the format. So format helps us in, if we don't have this format, what happens, I'll tell you. np.save.txt test2.txt. Okay. X. I'm not mentioning my delimiter is 1. Delimiter is which, like, as you're dealing with pandas, you'll understand that the files are of different types, like CSV, comma separated, tab separated. So here my delimiter is comma. So now I have saved it with format in test.txt. Without a format, I have saved in test2. Now let us try to open that and see. So here is my test.txt, which is cleanly formatted, like beautifully formatted 0, 1, 2, 3, 4. If I don't use a format, it turns out to be test2.txt, which is like numbers with lot of like exponential values. Like that level of accuracy is what it gives to the numbers. So these kind of numbers, we cannot usually use them reproducible, right? So that's why we use format. So this is about so that's about the saving the final NumPy array. So that is the total session that we have with respect to NumPy arrays for today.
Great.
Yeah, and there are a few links that I have given for the original documentation and the cheat sheet as well in the file PPT, which has been already shared with you. You can go through it and understand much more about the syntaxes. So now we are open for discussion. Thanks a lot for making me a part of this.
Yeah, I think someone is asking how to import a data set. I think we maybe we told we would cover that, but I think that should be the trivial part if I'm not wrong. Or yeah, maybe yeah, we already got a question about it. Lorento probably will try and address that in a different session altogether. Yeah, and
so what
do
I
you
would
want to
like
show
to
it?
add for okay, wait. Yeah, I'll show it.
Great, perfect.
Yeah. So for this we use something called as pandas, which is like most. So I'm importing pandas as PD. So for that now I want to save this. I want to create this iris dataset because it is in the same folder right now. So it would be easier for me. So all that you need to do is pd.read CSV because it is a CSV file and give the name of it, which is iris. Yeah, it is iris.csv. Now this iris1 is nothing but so it has all this is how I imported the data.
Yeah, perfect.
So Pandas has like lot of ways in which you can download data from different formats, like text data. Here I use CSV. You can text data is even SQL or XML, any kind of data. So in Pandas, you will be covering all that. Yeah.
Yeah, great. I think this line of code definitely helps. So yeah, it's very intuitive that way and easy as well. I think if there are any other questions people can ask. I mean, but to be honest, yeah. Sorry, Gunika, go.
No, someone has the difference between NumPy and SciPy that you mentioned before.
Okay. SciPy is built on NumPy. So this SciPy has more complex mathematical functions. So as we have seen that sine cos functions, right? Those kind of functions are available with SciPy. Even machine learning models are also available with SciPy, which can be used in combination with NumPy.
Okay.
Yeah, thank you.
Yeah, I think generally we use pandas for data analysis. Does it hold edge over NumPy? This is
So it's not like an edge over. They go hand in hand. Like few
right.
of the operations can be performed very nicely with pandas. Few of the like particularly with multi-dimensional space, nothing can help you out much better than NumPy.
Right. Cool. And while performing mathematical operations, do the columns and rows need to be same for both? Example, what if we add 5,1 array with 6,4?
Can you please come again with the question?
While performing mathematical operations, do the
Yeah.
columns and rows need to be the same?
Yeah, like if you want to perform an additional operation or something, you want to have same columns. No, it's not about this shape, but it's about the size. You saw that, right? No,
Right.
it's about the shape as well. They need to be of the same dimensions, but because of the broadcasting concept, it can replicate and we can create.
Right. I think in broadcasting, we can definitely do that. So
Yes.
I think Mahika was asking what if we add 5,1 array with 6,4? How does it look like? I mean, this is what she was asking, but I think that addresses to some extent.
Yeah.
So yeah, any particular reason why during addition the column matrix repeats itself to match other array size?
No,
Instead
it's
of-
not about the column matrix or the row matrix. It's about the smaller array repeating itself to match the size of the bigger array.
Okay, great. And yeah, I think we don't have many questions. I think, like, we got a lot of questions in between the session. Now we are getting just thank you messages on YouTube. They're saying it was a great session. It seems a lot of passion and hard work has gone behind it. And I think personally I enjoyed the way you picked the questions in between. Initially it was a little faster, but I think gradually, like, we got into the groove, and it went very well. And
Thank you.
thanks a ton for that, Gayatri. And
Yeah, I completely agree. We have a lot of appreciation in the YouTube live chat right now.
Oh,
yeah,
thanks a lot.
yeah, and yeah, thanks a ton for that. And also on the other end, for the learners, I think, like, as Gayatri mentioned couple of times, like, she said, like, she will like, check it out herself and, like, get back to you with the updated code, right? It doesn't necessarily need like, you don't need to by heart or, like, remember each and every bit of the code. Okay, you can reuse a lot of code. The thing is, when you are starting for the very first time, you may not be able to write all of it yourself. So what you need to do is you need to look at the code of others. I mean, like, for example, if we are giving you the notebook of Gayatri, you need to read it, comprehend and understand it well. Read each and every comment of it and understand. Even if you don't understand, don't worry. I mean, like, ask questions. We have Slack channel, like, ask more and more questions. And there we already have a bunch of coaches who are very proactive, and as you can see, they're almost responding in 2-3 minutes. I think that was the average ETA that I have seen so far. They're super active. So make most of it. Make use of Slack. And on top of it, I think don't get demotivated in the entire process. You will gradually get used to programming, and you can do some crazy stuff over time. And anything that you want to add, Gayatri, to the learners? Any suggestions that you have for the absolute beginners?
Yeah. So it's so rather than focusing on the syntax or like remembering what is the code, which is obviously available to you through Google and the original documentations are there, just try to understand where to use them, because data science is mostly an experimentation, right from pre-processing to modeling. Everything, lots, like there are lots of techniques available. You have to choose the one which is the best for your particular problem statement. So that kind of an intuition comes only when you know the concepts at a deeper level and you can comprehend what can be used at what time. So that kind of a thinking process, if you start right from now, that's why I have been giving you uh, helping you understand where a particular code can be useful. So if you learning it that way, it becomes very simpler and your thinking process also enhances. Also, yes, this data science journey is a little longer, but just don't give up. It took me about 1 year, I guess. Whole of my third year engineering, I was learning. That helped me land up with the internship in the final year itself, and from there I learned a lot of things on the go. So just don't give up. Give a consistency is what helps you out in like getting through this journey. And there are really good opportunities and exciting work there in data science. So all that you have to do is work and grab that opportunity. All the best.
Totally. I mean, like, and I totally agree. I think you have put it brilliantly. Yeah, they just need to emphasize on yeah, not just on, I mean, like, the syntax and all these things are, like, I think they can get the code available out there on Google. They need to understand the problem solving bit and also underlying concepts, and they need to
Yeah.
get their fundamentals right. That's spot on, I guess. Yeah. And thanks a lot, guys. Thanks a lot to all the learners, as well as thanks a lot, Gayatri, for your time. And yeah, thank you, and take care.
It was really brilliant from your end as well, Chanukya. I'm really thankful to DPhi for giving me this opportunity.
Thanks a ton. And, like, we really loved the session. Thank you. Yeah. And take care.